Okay, so today we're going to learn something called rationalizing the denominator. And before we get going on that, let's say I had the square root of 5. If I multiply that by square root of 5, I would get the square root of 25. And this is really because, which you know, I guess, is 5. So this is really because this is really the square root of 5 squared. And we know that squaring something and square rooting are inverses of each other. So really the square root and the squaring cancel each other out. So we end up with 5. And either way you get there, you notice that. So this is an important concept that we're going to use today. Okay. All right, take a look at this image here. View the blocks from that orange dot right there and the direction of the arrow. Which image on the right would be the correct view? Okay, so we're going to do something called rationalizing the denominator, and really what this means is it is bad form in math to have a radical in the denominator of a fraction as your final answer. So what we need to do is get rid of that radical. And one of the ways that we can do that is multiply it by itself, because like square root of 5 times the square root of 5 becomes 5, okay? Or square root of 25, which we know is 5. So we're going to use that fact to help us out. But the key thing here is to remember we cannot have a radical in the denominator as part of my final answer if I have a fraction. Okay, so first thing you always want to do when you are dividing is see if you can simplify. So this is what we were doing before. In this case, that means I would look at the 3 and the 2 and see if I could reduce that. I can't. I would also look at this right here and say, can I simplify it or break that apart? I cannot. So actually, this answer would be completely simplified. The only problem is now I do have a radical in the denominator or the bottom of a fraction. I can't have that. So what we do to get rid of that is we multiply by a special form of 1. So we're going to multiply. You know that if I multiplied by this by 1, I would still get the same thing, right? So what we're going to do is multiply by a special form of 1. And that would be the square root of 5 over the square root of 5. Anything divided by itself is still 1, so this is really still 1. But what that will do is we'll end up getting rid of this. We'll end up getting rid of this square root of 5 times square root of 5. That'll end up getting rid of the radical. And you'll see what I mean. Here we go. Let's multiply the top. We would get 3 times the square root of 5. And on the bottom, we would have 2. Now, square root of 5 times square root of 5 is square root of 25. Eventually, you're going to get good at this, and you probably won't do that part anymore, but we'll just show you this first time. You know that square root of 25 is 5. So this is really, my answer would be 3 root 5 over 10. Now, before I finish this off, I want to look at 3 and 10 and see if I can reduce those. Is that a fraction I can reduce? No. And I can't break apart that top anymore, so we're good. This is my answer. Now notice I don't have a radical in the denominator anymore. This is called rationalizing the denominator, and this is something that you'll see quite a bit. Okay, so there we go. Rationalize the denominator there. And now what does this look like for some other problems? So let's take a look at this one. Okay, always you want to start by trying to simplify. This is dividing fractions or dividing radicals, excuse me, still. So I want to say, all right, 8 divided by 15. Well, that doesn't work. That's not a nice number. So then I would say square root of 8 divided by square root of 15. Now, I want to keep going and try to simplify this. So I would say, oh, I can break apart the top. That would be square root of 4 times square root of 2. The bottom, square root of 15, I cannot do anything more with. Okay, so I would still be here. All right, so now I'm going to simplify the top. And I would have 2 times the square root of 2 over the square root of 15. Okay, now everything is simplified. The only problem is now in the denominator, I have a radical. Okay, so I have to get rid of that, and I have to rationalize the denominator. So I'm going to go and multiply by a special form of 1. So this would be square root of 15 over the square root of 15. Okay, that's 1 really. So I'm not changing anything, I'm just changing the way it looks. So this is 2 root 30 over the square root of 225. Now that's 15, so you might start getting used to this. Instead of writing that, you might just right off the bat go, oh, that's positive 15. Okay, because square root of 15 times the square root of 15 is square root of 225, which is 15. So now I want to look at this 2 and this 15 and see if I can reduce that. Nope. And then I want to also see, can I break apart the square root of 30 at all and simplify that? No. So my answer then would be this right here, okay? And I'm all done. That's my answer. But now notice again, in the denominator, I do not have a radical anymore. So we've rationalized the denominator. Okay. Next, let's take a look at this one right here and just kind of practice here. Again, try to divide if you can. And I can't divide these two. And I can't divide 12 divided by 7 either. That's not going to work out so great. So then I want to say, all right, can I break apart 12? I can, right? Okay, so this would give me 3 times 2 times square root of 3 over 4 root 7, which would be 6 root 3 over 4 root 7. Okay, so now I actually could reduce this. So I would have 2, oops, excuse me, I would have 3 over 2, right? I just reduced the 6/4 to 3 halves. All right, so now everything is broken apart. Now I want to get rid of that radical in the denominator, so I'm going to multiply by square root of 7 over square root of 7. So this would give me 3 root 21 over, and notice I didn't multiply by 2 root 7, just root 7. So 2 times square root of 7 times square root of 7 is square root of 49, or 7. So my answer here would be 3 root 21 over 14. And again, I want to look at the 3 and the 14, the coefficients, and see if I can reduce. Those are already reduced, so I'm good. Okay. I think we'll come back to this one, or maybe if you have questions on this one, we can talk about it. But I want to move to some of the other ones here that get a little bit crazier. All right, so this first one we already did, so I don't want to go through that one again. Now notice this other one here, we sometimes have situations where I have a binomial. So in this one, everything is simplified here, but I have 2 terms on the top. So what I'm going to do then on this one is just multiply. I need to get rid of that square root of 2 on the bottom. Okay. Now it's a binomial, so I'm distributing. So I'm really going to go square root of 8 times square root of 2, and then negative square root of 2 times 2. So really kind of like this, right? All right. So that would give me square root of 16 minus the square root of 4 over square root of 4. And sometimes this works out kind of nice. So here we end up with 4 minus 2 over 2, which is 2 over 2, or just 1. And that's my answer. Crazy. Okay, now, if you have a binomial, so notice here at the top, it says multiply the numerator and the denominator by the conjugate, which is the same expression but with the opposite sign in the middle. So its conjugate, they always go together, and we'll learn more about that as we get into polynomials. But what we want to do is look at this now and say, all right, well, I can't do anything more here. This is all simplified, except I need to get rid of this square root of 7 in the denominator. So what I'm going to multiply, this time I can't just multiply by the square root of 7. That won't work. I will still end up with a radical in the denominator then. So this time I have to multiply the top and the bottom by its conjugate. The conjugate is the same thing but with the opposite sign in the middle. So notice 2 minus 2 root 7. Okay, now this, if you multiply this together, you will get no longer have a radical in the denominator. So now on the top, we have to distribute everything. So I'm going to go 3 times 2, 6. I'm going to go 3 times negative 2 root 7 would be negative 6 root 7. Now I'm going to do square root of 7 times both of those. So this would be plus 2 root 7. And then square root of 7 times negative 2 root 7 would be negative 2 root 49. Now we're going to do the bottom. So 2 times 2 is 4. 2 times negative 2 root 7 would be negative 4 root 7. And then 2 root 7 times 2 would be 4 root 7. And then negative 4 root 49. Okay, now we're going to clean all this up. So let's do that. In the top, we would have 6 negative, if I put these two together, that would give me negative 4 root 7. Remember, this is 7, so this is minus 14. 2 times 7. All right, on the bottom, these combine and cancel out. We have 4, and then once again, this would be 7. So minus 4 times 7 would be 28, so minus 28. All right, we're going to keep simplifying this. So on the top, I would have 6 minus 14 would be negative 8, and then minus 4 root 7. And then this would be negative 24. Okay, now you're done, except you always want to look at these numbers right here and see if they have anything in common that you could reduce, okay? Now, the biggest number that goes into all of those would be negative 4. They all have a negative in common, so I'm going to use a negative. So negative 4, if I divide negative 8 by negative 4, I get negative 2. This would be 1, so plus 1 root 7, or just root 7. And then negative 6 divided by, or negative 24 divided by negative 4 would be negative, or positive 6. Okay. There we go. There's our answer. All right. Okay, let's go to the last one. So this is the same kind of thing, but just to get some practice with this, so you see another one, let's go through this. And that's it. So this one, I want to multiply by the conjugate of this. So this would be 3 plus 4 root 6. But I'm going to put that on the top too. Okay, and this one I'll go a little bit faster than I did on the previous one. So here we go. 24 plus 32 root 6 minus 3 root 6 minus 4 root 36. That would be the top. On the bottom, we'd have 9 plus 4 root 6. Oh, excuse me. Plus 12 root 6 minus 12 root 6 minus 16 root 36. Okay. So now let's simplify. The top here we would combine the middle. That would be 29 root 6. And then this is 6. So 4 times 6 is 24. So minus 24. Okay. And then on the bottom, these in the middle would cancel. This is 6 again. So negative 16 times 6 is negative 96. So I'd have 9 minus 96. All right, so if I simplify this, I end up, these cancel out. I have 29 root 6 over negative 87. All right, now I want to look at this and see if I can reduce. I can. 29 does go into 87 3 times. So this would be 1 over negative 3. So 1 root 6, or just root 6, over negative 3. And that is my answer. And this is how we rationalize the denominator. Try to give you lots of examples to help you out. Hopefully that helps. Go ahead and give the worksheet a try. If you have any questions, come and see me. All right, bye.